Imagine this. You and I each get one magic coin. I'm in New York. You're on Mars. I flip mine, it lands heads. The exact same instant. No signal, no radio, no light speed delay. Your coin on Mars is guaranteed to be tails. Every single time. Einstein called this spooky action at a distance and spent the last 30 years of his life trying to prove it couldn't be real. He lost. And what he lost to is about to rewrite computing, encryption, and maybe even reality itself. Today we're talking quantum entanglement, the weirdest, most proven, most powerful thing in physics. Stick around, because by the end you'll understand why scientists say we're on the verge of a second quantum revolution that makes the first one look like child's play. Okay, picture two electrons that bump into each other and then fly apart. In the normal world, once they separate, they're independent. But these two electrons are now entangled. They share one single quantum state, one fate. If you measure this one and find its spin is up, the other one, no matter if it's in the next room or the next galaxy, instantly becomes down. There is no before for the second particle. It literally didn't have a spin until its partner was measured. That's not sci-fi. That's the Bell state, the simplest form of entanglement, written like this: psi equals 1/√2. Don't worry if the symbols look scary. It means these two particles are opposite, but neither one knows which is which until someone looks. Einstein hated this. In 1935, he and two friends wrote the famous EPR paper saying, "Quantum mechanics can't be the full story." For 30 years, it was just philosophers yelling. Then in 1964, an Irish physicist named John Bell said, "Stop arguing. Here's a math inequality. If hidden variables are real, experiments can never break this limit. If quantum mechanics is right, they will." First big test, 1982, a land aspect in Paris. Result? Bell's limit shattered. Quantum mechanics wins. 2015, Delft University in the Netherlands. They put two electrons 1.3 kilometers apart, closed every known loophole, random measurement choices decided by flashing LEDs. Still violated Bell's inequality by a huge margin. Local realism is dead. The universe is non-local. Deal with it. And yes, before you ask in the comments, nothing travels faster than light. You can't send messages with entanglement. The outcomes are random. You only see the correlation when you phone your friend later at boring old light speed. So if entanglement is real, why isn't my coffee cup entangled with the moon? Fragility. It's called decoherence. The moment an entangled particle bumps into air, heat, or a stray photon, the information leaks into the environment and the magic dies in billionths of a second. That's why the macro world looks normal and only tiny, cold, isolated things stay quantum. We're learning how to keep particles entangled long enough to use them. Welcome to the second quantum revolution. First, quantum computers. A classical computer with 300 bits can be in exactly one of two superscript 3 possible states. A 300-qubit quantum computer that's fully entangled? It's in all two superscript 3 states at the same time. That's more states than atoms in the observable universe. Google, IBM, China, everyone is racing. When we get stable logical qubits, goodbye RSA encryption, hello perfect drug design and climate modeling. Second, unbreakable encryption, quantum key distribution. Alice and Bob share entangled pairs. They measure, get a random key no one else can know. If Eve tries to listen, she disturbs the entanglement. Error rates spike. Alice and Bob notice instantly and throw away the key. China already has a 2,000 kilometers quantum network. Europe and the US are building theirs. Third, insane sensors. LIGO detects gravitational waves using squeezed, entangled light, beating the normal quantum noise limit. Ghost imaging. One photon hits the object and dies. Its entangled twin never touches the object, but still lets you reconstruct the picture. Here's where it gets deep. Bell's theorem says we have to give up either realism or locality. Most physicists gave up realism. Things don't have definite properties until measured. Some go further. The many worlds interpretation says every measurement splits the universe. You and I are entangled with everything we've ever measured. In the next 10 to 20 years, new drugs discovered in weeks instead of decades. Financial models that actually predict crashes. A global quantum internet using satellites and quantum repeaters. But also, Hugh Day, the day a big enough quantum computer breaks all current banking encryption. Intelligence agencies are already harvest now, decrypt later. And the quantum divide. Only rich countries and megacorporations will have access at first. Final thought. At the Big Bang, everything was entangled. Some physicists think tiny threads of that original entanglement might still be out there. In other words, we never stopped being connected to every star and galaxy. Entanglement isn't just tech. It's a reminder the universe is one giant, holistic thing. So yeah, Einstein's spooky action turned out to be the least spooky thing about reality. It's the thread holding the cosmos together. If your brain hurts in the best way, do me a favor. Smash that like button, subscribe, and tell me in the comments which part freaked you out the most. The multiverse? The unbreakable encryption? Or the idea that you might literally be quantum connected to the Andromeda galaxy right now? Thanks for watching. Stay curious and slightly entangled.